Yankee Cucci. I am located in Research Triangle Park, and I'm part of this group called the IBM North America Big Data Technical Team. First and foremost, I'd like to thank you for taking time out of your busy schedules to attend this session. As Amanda mentioned, today I'd like to step through a way to unlock insights using real New York State restaurant inspection records. The data we'll be using is publicly available on the internet. I'm showing the location right now. It's actually located at the New York State Department of Health. And basically it has a whole list of all the inspection records. And I can export that data using various formats, such as JSON and tab delimited format. But I decided comma delimited format. So that's the data format we'll be using. In addition, we'll be using Data Science Experience to analyze this data, visualize the insights, and as well, we'll apply some machine learning. So Data Science Experience can be accessed by just pointing your browsers to datascience.ibm.com. And it's here where you can sign up for a free trial as well. Just a few short words on DSX. If you're not familiar with it, it's basically a cloud-based, interactive, collaborative environment that makes getting data insights and machine learning as simple as possible. It provides the best of open source tools like Jupyter notebooks and RStudio, but it also provides a valuable community to learn and enhance your data scientist skills. Of course, under the hood, Spark is the underlying workhorse engine. So let's go ahead and log in. And when you first log in, you'll be presented with what we call a community page. This shows recent articles, data sets, notebooks, and tutorials that can help you, or you can refer to them in your projects and code. You can hover over different ones, but as you notice, they're just not from IBM, but from the larger community in general. So here's one from something called Sharp Sites Lab, which says why you should master art, blah, blah, blah. Let me be very clear, et cetera, et cetera. So you can get more information if you hover over it. And if you click on it, you basically go to that, in this case, it looks like a blog. And you can read about it there. If I hover down or scroll down a little, you'll see that there's some data sets, notebooks, and tutorials. These are very helpful, have been very helpful to me to learn about things that I may not have known, like how to access Postgres or DB. You notice here on the data sets, these are public data sets that you can start to experiment and work with your data scientist skills and try to see what you can do. There's only one right here because that's the most recent, but there are many, many others. If I click on View All, you'll see things from the U.S. Census, Airbnb sites, all kinds of stuff that you can work with to get your data science experience started. Or if you're looking for a specific topic, in my case, we'll be using, I think it's pronounced Brunel, but it looks like Brunel, but Brunel, to visualize some of the data about these New York State restaurant records. So this is a very helpful notebook that I found. I'll click on it, and it basically shows me a number of different visualizations that are really cool. Things like scattergrams, or what do they call these? I think they call these chord charts, chord plots, but this can all be done in Brunel. And also, let me go back and show you that any of these things can also be bookmarked so that you can always find it when you need to. So let's go from the community page into My Projects. So I'll click on the left button here, go to My Projects. You'll notice that I'm a part or working on different projects. The one that I want to work on, obviously, is the New York restaurant demo. Projects are a great way to organize analytic assets, data assets. You can create bookmarks and include collaborators. So if we look at analytic assets, we'll go into much more detail on this in a moment, but these top parts are Jupyter notebooks, and the bottom ones are pipelines for machine learning. If I look at data assets, it's kind of really just showing three comma delimited format data sets that I'm using, and I can drag and drop anything over into this little box here to add data, or I can actually create what we call connections. So if I click on Create Connections here, you'll see I can name the connection, and if I happen to have some Bluemix, these are like Bluemix services that you might have. I have two cloud and NoSQL databases running. I have DB running on there. I can connect to those. Probably more apropos here are the external ones, for example, S3, CloudEnt, DB2. There's quite a few variations of various data sources that you could create. If I look at bookmarks, remember I mentioned I found some really good stuff about Brunel, and I have that notebook. I also have a tutorial that I went through, and it really helped me to understand what I could do with it. As I mentioned, the community is a very valuable part. So if I want people to collaborate and help, work with me as a group, I can always invite them and add them as collaborators and specify a permission, role-based as viewer, editor, or admin. Yeah, so let's go ahead and take a look at the analytic assets. I want to take a look at these Jupyter notebooks, but before I do, I've already created this notebook, but there's always a need, especially if you look at GitHub or some of the other open source repositories. There's at least in GitHub alone 200,000 Jupyter notebooks. Wouldn't it be nice, and it is nice, to be able to import these into DSX very simply? So I can add a notebook. I can start one from scratch using Python, Scala, R, or Python 3.5, which is kind of in an experimental beta state. Or I can, and also specify which Spark kernel I want to use, a 1.6 or 2.0. I can import a Python notebook from a file locally on my workstation, or I can do it from a URL, which really applies when you're talking about doing something for bringing in notebooks from GitHub. So for now, I'll just type in test. I'll go over to my GitHub, and I happen to have one here. If you notice, it's in this DX Kikuchi, which is my GitHub account in a DSX integration thing. So if I take the link, I go back here, and I just copy it here, I can just create notebook and easily import one of those 200,000 Jupyter notebooks that I might want to use or share with other people. So there it is. But let's go back into my project and go use the one that I just created, or I'm working on for this particular demo. And that's called New York Restaurant Notebook. I want to open it up in edit mode. So as I mentioned, GitHub is pretty cool. We do have a local versioning capabilities. So if I click on here, you'll notice that I have three versions available. So I can save up to 10 locally just for me. In a world where you're talking about groups or sharing, then of course you might want to publish it to GitHub, which is what I did previously. And I can go ahead and click publish here. And it will tell me it was published. And I can just click here to actually view the content. So again, it's going back out to my GitHub, the Kikuchi, and you'll notice that this was published a few moments ago. Let's go back here. DSX integration. Yes, sorry, 23 seconds ago, this particular notebook was published. So a lot of round-trip capability to be able to do that and share. If you just wanted to share the notebook, we can also do that just by sending a person a link. So I can share it with anyone with a link, and then they can get to it. And one other thing that I'd like to show up here before we actually go into the notebook is the scheduling capability. Really kind of neat for any notebook that you might want to run, say, every week or every day or every hour, month, year, etc. You just need to specify that and what version of the notebook you want to run, and it will do it. So say maybe my New York State restaurant inspection records are updated on a weekly basis. I could import that, and then well, I just have to bring the data over, and then it will run the notebook every week to keep it up to date. So now let's get into the actual notebook itself. Oh, you notice that I'm running with Python 2 on Spark 2.0, and if I wanted to, I could go into the kernel. I can easily change the kernel into another Python version, or R, or Scala, and again, the different Spark 1.6 or 2.0. So in this notebook, what I'd like to do is take those New York State inspection records and get some visualization, some insights into it. I'd like to say that it has basically, if we go through this whole notebook and look at it, there's basically, if you look at these code cells, there's 16 lines of code to do that. It's really less if you subtract out the declarations and a few other things. But to be true, it is exactly 16 lines of code right now. So let's go ahead and do the first thing. If you notice here, let me actually open this all the way up as much as I can. The first line actually is a pointer to where the data resides or exists. So basically, I will go ahead and execute that code. The next one, I'm going to take something called Pandas. Pandas, for those of you not familiar with, is an open source Python library for high performance data manipulation structures and things of that nature. So in this case, I've defined pandas PD. I want to read a CSV file from that pointer and then do it NYR head, which basically just lists the first 5 records. So here are the first 5 records, 0 through 4. It lists the facility or restaurant name, its address, the date it was inspected, the violations, the number of critical violations, the county it's in, and most importantly for what I want to do for this demonstration is to look at location 1. This is in latitude, longitude of the location of that restaurant. Let's scroll down a little more. What I'd like to do, especially if you're dealing with big data, you want to narrow it down as much as possible as you analyze it. So the only things I really want to see are the facility, the total number of critical violations, and the location, which is the latitude, longitude. And there. So now my data frame only has those columns. And the next thing, notice that these latitudes and longitudes are in parentheses separated by comma. In order for, when I read Bob Brunel, I need to have a separate column for the latitude and separate column for the longitude. And the easiest way that I know how to do it, there are of course many ways to cut the cake, but I decided to use SQL. So I basically defined that particular data frame as a SQL table, and then I created a query. The query basically says select the facility, and then also use regular expressions to extract out the latitude, the longitude, and then the number of violations. I then want to order it by the number of violations in descending order, so the most violations show on top, and I'll limit it to 1,000 records. So it'll show me at least the top 1,000 most problematic restaurants. And here they are. The top one, the top offender, is something called Landsman Cafe. It's at latitude 41.76024 minus longitude 74.598. It had 23 violations, and you can see them in descending order. Cool. So now what I'd like to do is actually use Brunel vision, and basically map this. And as I mentioned, all I do is pass the latitude and the longitude. The color key will actually show the number of violations and the tooltip, so when I put the cursor over it, it will tell me what the facility name is. So we'll run that cell. Oops. Oh, it doesn't define New York Pan. Bear with me a minute. Let me actually rerun these cells just to make sure, because it sounds like that I skipped a cell in which it didn't get defined. This is a great part about live demos. I can't say, I'd have to actually debug this, but let me do this as a safeguard. So I'm going to go back to pick up a version that actually had it working. I just happen to have this handy, so this will show versioning. I will revert back to this particular version. And this is how it should have been rendered. Not sure exactly what happened. We can look into it and debug it at a later time. But I would have to debug it. But for now, here's what we would have seen. It's a rendered version of all those high violation restaurants. If you notice, there's a couple of them. So this one over here is called Camp Kingsley-CC. I'm guessing it stands for Country Club. But it had a number of violations, probably on the order of 10. And if I scroll in a little more, Yeah, so I see another one down here, and this one's called Holiday Mountain, and it has a much darker type of key, so it has probably more violations. So let's take a look and see how we might be able to find out more information about this. The way we would is by using something called pixie dust. It's just another way to do it, not saying that this is the only way, of course, but another way to look at it being pixie dust is what is it? It's another Python library that basically allows for data visualization, and we can do things like once the chart's up, we can see the table. I can type in camp, and Camp Kingsley-DC actually shows me with 10 violations. And the other one was holiday something, so if I type in Holiday Mountain had 14 violations. So that's part of the visualization. I can also visualize things by selecting different kinds of graphs and charts that pixie dust also provides. So in basically 16 lines of code, as I mentioned, I was able to find a lot of good insights, I believe, on this restaurant data and what it can provide. By the way, I will mention that if you want to actually try it out yourself, and we can go to a site here, and it's hopefully easy for you to remember, but it's ibm.biz/DSX-demo. And this will take you to our external website, so it's available for everyone, and you'll actually see the demo in a different variation or format, but it's basically the same information. But more importantly, you can actually try it yourself. I've written a tutorial on it, and it goes step by step on how you might want to be able to try this out yourself. So that's Jupyter Notebooks. I just wanted to leave at least that kind of impression and go into machine learning at this point. Okay, so I will go back, and I will go back into my analytics assets. Remember, I told you on the top here we have things that are dealing with Jupyter Notebooks. Down here we'll deal with machine learning types of capabilities under analytic assets, one of which is New York restaurant violations. So this particular capability is in beta right now in DSX, and it provides the capability to create, train, and deploy machine learning models. Of course, this can be written in a notebook. You could code it by hand, but what we're trying to do again with the concept of DSX, or the premise, is basically making this easy. So we're going to show this beta capability right now, which will be available soon, and we'll be able to show it to you without having to do any code. Machine learning, for those who don't know, basically allows computers to learn and find hidden insights without being explicitly programmed to do so. And it can change when exposed to new data. So obviously new inspection records are coming in, we could rerun the model and just keep it updated. This could relate to different other things like clustering or classification or collaborative filtering. Collaborative filtering is basically like a recommendation engine. So if you've ever been to Netflix and it recommends other movies, that's what this machine learning capability is doing for you. Or when you're on Amazon and you're looking for a certain book and they recommend others. So that's what we'll take a look at. We'll go to the New York restaurant violations pipeline. Basically, it asks me at this point, what data set do you want to analyze? I want to look at the violations. So I'll click next. This is just to keep it simple and easy for the demo, I've limited to 3 columns. One of them is something called a label, which is the is violation. So basically we did some data preparation or munging or wrangling, and basically what we took is that same data that we had before, and if there was a high violation, we said true, and if not, it was false. We also pulled out the county and inspection type, which I'll be using as features. So typically when you look at the data, you want to look for and consider what we call observed feature items that may predict the output label. To keep it simple, like I said, we just did 3 columns. We used a string indexer, so these are all transformations. I can add a transformation. And there are a number of them that are there right now, and it will be enhanced in the future. We have binarizers, bucketizers. The one that I used is actually down here in the bottom called a string indexer, so it converts a string into a column of labels. So for this particular one, I string index the county, and the output will be county code. did the same for the inspection type, and then I put that into a vector, which is what the machine learning algorithm is really going to want. It's going to want it in a vector form. The only other last thing I did here was the string indexer on the is violation, and I made that or called that label. Okay, so the next thing, oh, and these are all transformers. So if you think about it, in machine learning, there are transformers and estimators, like in Spark. In regular Spark core, there are things like transformations and actions. Very similar. So typically, transformers in the machine language world take in data, manipulate it, and spit out data. Estimators typically take in like vectorized data and implements a specific algorithm, and then returns a model that you can use for predicted data results. In this case, I'm going to press next, and this is where we define an estimator. We would define what vector is actually the features. I'm sorry, the label, and that would be is violation. And then here we would pass in the actual features column, which is the vectorized data. I'm using a logistic regression model. There are many models that are estimators that are available. Linear regression, logistic regression. As I mentioned, I chose logistic regression. It's basically what we call binomial logistic regression, and there's a lot of math behind it that I maybe don't understand, but basically what this algorithm does is it's a statistical method for analyzing the data in which there are one or more independent observation features that predicts the probability or outcome, or labels, in which, in this case, since it's binomial, it's either going to be true or false. It's going to be 0 or 1. So at this point, if I were running this, it would train the data. It would train the model, and the model results would be here. It's already done it for me since I did it before. It does say the performance is poor, probably because the area under the ROC curve is 0.5. What does that mean? Well, ROC stands for receiver operating characteristic, and it's basically a plot of the true positives against the false positives. And if it says 0.5, we're basically saying it's a 50-50 chance of going true or false. It's not any better than like flipping a coin. So this is not a great model. It's not, I would probably need to add some more observation features or other things that I think might affect it more effectively, and then I could run it. But just for concept's sake, it's very simple to create a model this way. We would also evaluate it, and we could deploy it. And then once it's deployed, it will give me this nice screen where I can actually try it. So in this case, this is some county called Chemung in New York. And if I could predict, it will tell me the predicted value will be 0 with probabilities of 0.83. So about 83% will be false and 16% will be true. Just to show that it's not. I'll put in Westchester County. And in this case, we have again, a predictive value of 0, false, so that true, where you might have a restaurant that has violations at 12.5% or 0.125. So very easily being able to create a model, train the model, deploy the model, and now I can use it within a notebook. So I'm going to go back to the same notebook we used before, the New York restaurant notebook, the Jupyter notebook. Again, this is just a Jupyter notebook where you can put in code, and then you get basically results as you go along. So in this case, I will run this code, this cell. It's basically passing in some parameters, and then I'm also passing the payload here. But bottom line, it basically went over, kicked off that model, and came back saying for Westchester, here we are again, 0.125 as the result. And just to show that it is calling the real model, I think it was called Chemung. And in this case, it's 16.595, and if you remember before, it was the same values. So again, this is in beta. There are plans for many more things for this, but you can see the value, hopefully, in terms of what machine learning can bring. In the future, you'll actually see there's an article out there by our offering manager, Armand, which talks about SPSS. SPSS is a predictive modeling tool that IBM has that's being incorporated into DSX. SPSS has a canvas concept, so as you notice, we probably did pick one, put it on the palette, pick one. But this one is actually drag and drop. So you'll have a list of, manipulators or models or algorithms that you just drag and connect via lines as a drag and drop kind of interface. And then once that's done, you can train the models, and these diamonds here represent the model themselves and run them. Much more, you can look at it, picture's worth 1,000 words. You can see what it's doing and understand that model pretty quickly. Oh, also, with SPSS, there is a future plan to bring what we call auto modeling. You may not know about, we use logistic regression. There's also linear regression. There's also decision trees. There's IDLs. There's all kinds of different algorithms, and I honestly don't know all of them, but what this will do with this auto modeling capability, it will run them and it will tell you what model gave you the best results and basically tell you which ones to use or which one is the best model that will make some predictions. So I hope that helps. That's what I wanted to cover on this New York restaurant inspection records, but I did want to show you another capability. It's going to use a different use case scenario, but there's an awful lot out there with R. R is a very popular platform. It's been around for a long time. There's about 2.5 million dedicated users. IBM has joined a consortium. We're one of 3 platinum members, along with Microsoft and RStudio. So if I go back into Data Science Experience, I mentioned that not only did we have Jupyter Notebooks, but we also have RStudio embedded within Data Science Experience. So let that start up. As I mentioned, we're one of 3 platinum members, which means we also have a seat on the board. We've announced full support of R, and the R users will benefit from all these IBM analytic products, I believe, that will provide native support for R. The bottom line, we are mutually aligned to make sure R is a first-class citizen in Spark, much like Scala and Java and Python. RStudio, this particular IDE that it is showing right now, is a not a startup, but it's actually been around since 2008, I believe, and it's headquartered in Boston, Massachusetts. And it's inspired by innovators of R users, and RStudio developer provides free and open tools. The use case scenario that I'd like to deal with here that's being shown is something that was created jointly with something called BlockPower. BlockPower is a company that's really into making buildings more efficient, more energy efficient, and these are buildings in New York City. And if we look through the code, I'm not real familiar with R, but basically there are different things like making sure to install the initial packages. There's a thing called Shiny, which will actually make this thing into a nice web application. I'll show that in a moment, because as a web application, all your business users and anyone who has access to the web can really look at it and do things with it. There's some declarations and definitions. And if I go just to the bottom here, there's some predictive models. There are 2 predictive models actually in this particular R code. One of them is for linear regression, which is shown in the plot on the right here, and the other one is for k-means. So the linear regression model is basically predicting energy consumption of different buildings in New York City. So here's the predicted usage and the measured usage and a linear best fit line to match that. We also have k-means model in here to cluster and classify buildings by energy efficiency as well. And as I mentioned, there's this thing called Shiny, in which I can run the document. It's trying to open external browser. I haven't authorized that, but basically I just say okay, and it'll open it in the browser. This is basically making that R code into a nice web application that anyone can use. The first screen will actually show a map of New York City on the left, and I can pick a certain, I can see annual interest costs. I can pick one of these locations here, and then I can find out that this particular building annual energy cost is $17.53 with 145% average energy consumption. I can also look at cluster analysis, which is the cluster k-means clustering algorithm model that was done. And you can see all these different buildings that also have energy efficiencies, or more importantly, inefficiencies. So maybe this one would be looked at very carefully, the CAAA bagels. And the predictive model, which is kind of nice because you can see that how it affects a building. You know, number of stories, number of floors in a building. In this case, it's 1. If I want to predict 2, well, it's only 30,000. Annual energy bill, 169,000 kilowatt hours. 3 doesn't really affect it that much, but what does affect it are things like plugged outlets. I mean, that makes it jump, or square footage. That makes it jump as well. So I found that kind of interesting. And then the actual table of data that actually used to use the prediction and run the models, etc. Block Power also has, close this, has created a really kind of cool interface that's running this thing as well. So you can look at all the things in more of a 3D kind of map and pick some buildings. So this one obviously stands out. I'll click on that. This is a building at 57 Watt Street in Manhattan. It's got 402,000 square feet, 23 stories, built so-and-so. And they say that you can save big. You can save 30% on electric bills, 40% if you discuss some of the things that you can do to make that more energy efficient. I was very impressed with that. That's about what I wanted to show in terms of data science experience. I hope, you know, it took a short amount of time to basically show that DSX can help, you know, help make data, make the analytics, make machine learning as simple as possible. And then RStudio is also included for people who are more inclined with R. So I hope that helped. I hope you found the session helpful. I welcome any questions, or if you want to see anything else, let me know. So, and I'd ask you if there are any questions on the chat, or?
We don't have any questions right now, but are there any questions in the audience?
It usually takes me more to go through this, but that's with an interactive, that's with a real face-to-face audience. So,
yeah, and there are no more questions. So thank you so much, Dan, and thank you everyone for joining us today.
My thanks too. So thank you for joining. I hope again you found this helpful. Have a great day.